In this section, it will be shown how to build the physical models of electrical drives using MATLAB and Simulink. The mathematical models were given previously in first sections. We believe that the best learning strategy is to practice what you learned. The physical model-based simulations are considerably more complex than those simulations purely based on differential equations, particularly when semiconductor switches and PWM modules are used in the simulations. The first building block embedded function for Park-Clarke transformation is for current measurements. The program or the embedded MATLAB file perform Park-Clarke transform to convert the two-phase current measurements to I alpha and I beta, then to ID and IQ currents. The second building block embedded function for inverse Park-Clarke transformation is for voltage actuation. The program or the embedded MATLAB file perform inverse Park-Clarke transform to calculate the three-phase voltage signals. A permanent magnetic synchronous machine Simulink block is used to simulate the dynamics of a PMSM. The following physical parameters are used to test this simulation program. For the modeling of the PMSM, I have provided you with a Simulink block. This can be used as a base to start the simulation. The controller should be implemented by yourself. All formulas for the design of the current controllers and speed controllers we have already calculated in the last videos. The complete PMSM speed control models I will of course provide. But my request is that you try to implement the whole thing yourself. Only this way, you can also make models yourself in the future, or even extend these basis models to future projects. We simulate the closed-loop responses by using PI inner-loop current control and PI outer-loop speed control. In the design of inner-loop PI controllers, the closed-loop performance parameters, the damping coefficient, and the bandwidth for both D-axis current and Q-axis current controllers are calculated in the init call function. And also, for the design of outer-loop PI controller, using the formulas already derived in the last lectures. Using this simulation, you can simulate and monitor cascade feedback control of speed of PMSM with both PI current controllers. Closed-loop response of the angular electrical velocity, the actual velocity, the reference velocity, closed-loop responses of the D-axis and Q-axis currents, the actual current, the reference current and closed-loop control signal responses for the D-axis and Q-axis voltages. So, the first target of this course has been reached. If you buy this course, you can also profit from the next updates. I will upload more sections from time to time. At the moment, I think to make these following upgrades available to you soon. Real-time implementation of current and speed controllers. MATLAB embedded functions of PI controllers. Operational limits in electrical drives control systems. Tuning PMSM control systems, and more. After finishing this, I will also provide you, from time to time, with state-of-the-art, electrical drives hardware-related tips and tricks. And please, use the questions section if you have any questions. I will guide you during your training.